Hello, today we will discuss about ICP-MS, Inductively Coupled Mass Spectrometer. So ICP-MS is a mass spectrometer with a difference that the ionization of the sample is done using plasma instead of electrons as in a mass spectrometer, typical mass spectrometer, where it is ionized, then accelerated and then subjected to a strong magnetic field. So ions which are heavier will be bent less within the magnetic field, and those which are heavier which are bent less, and those which are lighter they are bent more. So this ions within this magnetic field are subjected to the Lorentz force and the centrifugal force. So net effect will bend their paths. So this is the block diagram of a typical mass spectrometer. You have the ion source and it is accelerated and then going to a mass analyzer where you apply the magnetic field. So this is equivalent to a monochromator where you select the different wavelengths in a spectrophotometer, optical spectrophotometer. And finally there is a detector. Detector is typically an electron multiplier or Faraday cup, and it is the signal is processed. This is done in a vacuum. It's done in vacuum. So different types of mass spectrometers exist. The ICP-MS is one of them, and within this different types of mass spectrometers you have the mass selectors. This particular portion, the mass analyzer, which is equivalent to a monochromator. It varies. You have quadrupole type, time of flight type. We will discuss these two in this section. So this is a typical mass spectrometer. The sample analyzed, it is accelerated, then subjected to a magnetic field. Lighter are bent more, those are bent little, the heavy ones are bent little, and it is detected. So this is the setup. So this is what we spoke about, the Lorentz force, which is pulling inwards the ions in the magnetic field, and the centrifugal force which pulls it outwards. And finally this is the charge to mass ratio is the determining parameter. So ions are detected based on the charge to mass ratio. And this is a typical spectrum from a mass spectrophotometer. You have this spectral lines corresponding to the charge to mass ratio. Now this is a mass, we discuss about mass analyzers. Say one common type of mass analyzer is a quadrupole mass analyzer or quadrupole mass spectrophotometer. It's mentioned here. Here we have 4 rods or tubes, you can say that, and these are subjected to opposite polarity DC voltages, and along with that you apply alternating field also. So alternating field is varied in such a way that you can select a particular ion to pass through this tube, the space between the tubes, and reach the ion detector. So in such a way that at a particular point only one particular ion will be allowed into the detector and it is detected there. So this is the way in which you get a plot of the various ions within this sample. Now this follows the path, follows the Matthew equation. Matthew equation is given here. Another type of mass analyzer is a time of flight mass analyzer. So you have the ion source, and these ions, these are accelerated and then it is sent. So this area does not have any field applied, so it is accelerated and then it's subjected to a deflection to reach the detector. The time of flight depends upon, the time of flight is used as a parameter. So each ion moves through this flight path, the free flight tube, depending upon its with a velocity which is dependent on its charge to mass ratio. It depends on the charge to mass ratio. So and on the basis of that you will be able to detect the, what do you say, so if it is, since this distance is a fixed distance, we will be able to separate the various constituents depending upon their flight path, time of flight path. Then ICP-MS is a very widely used technique. I have included a video of a product ICP by Shimadzu. So in the classroom, so you see that product, how it's a brief video which describes how it works. Now this plasma torch is a mechanism which is used to generate the plasma in ICP-MS system. So plasma torch has a RF coil around it, and you introduce inert gas which is first ionized, and why it is subjected to a very strong RF field, and by induction it is going to get transformed into a plasma. Then you introduce a sample along with the carrier gas, so they also get ionized. You have a cooling gas also introduced to cool this mechanism, and finally this is introduced into the system. So there is a mechanism called as an ion lens, which is used to, it's an electrostatic mechanism to get a coherent beam of ions. So they will get a coherent beam, and here you have the quadrupoles or the time of flight mass analyzers, any of them, and finally you detect. So hope this makes it clear to pick up the topic from the material shared in the classroom. Okay, all the best.